Assalamualaikum and good evening, everyone. Today we are from L03-B02. We're gonna present our project title, Stack Implementation for Browser Back Button. Okay, I'm Ridwan Arman bin Ismail Bahman.
My name is Azmi bin Sayusin.
My name is Said Farihin bin Said Faisal.
My name is Sharif Nur Shoimi bin Sharif Kabir.
So, application description is for Said Farihin.
Okay, application description. The browser back button lets user quickly return to previously visited pages. It helps user reverse their navigation steps, providing a way to go back earlier content without re-entering the URLs or restarting their session. It works like a stack. The last page you visited is the first one you return to. For example, if you visit A.com, B.com, or C.com, pressing the back takes you to B.com, then A.com. This makes a navigation smooth and efficient.
All right.
How is it work? The go back button in a browser works using a stack-based history system. Here's how it function. Browser history stacks. The browser maintains a stack of visited pages. Every time you navigate a new page, the current page is pushed onto the history set. Going back, when you click back, the browser pops the top page from the stack, the current page. Then it loads the page underneath with the last page you visited. All right. In this, I will pass it into Ridwan Arman.
All right. So, why are we using stack for this? Last in, first out, or we call LIFO order. The stack is ideal when the most recently added items needs to be accessed first. This is perfect for managing tasks like undo operations, backtracking, or function calls. Next is functional call management. Stacks are used by most programming languages to manage function calls, local variables, and return addresses via the call stack. And lastly, memory efficiency and control. A stack uses contiguous memory, which is fast and efficient. Also, it provides controlled memory access, and you can only access the top, reducing bugs from random access. All right, next is push/pop operations. For push, the push operation adds an element to the top of the stack, and then pop operation removes the top element from the stack. All right, next. Okay, pop operations. Check if the stack is empty. If it's empty, there is nothing to pop, and this condition is known as a stack underflow. Also, if the stack is not empty, proceed to remove the element that top is currently pointing to. After removing the element, you update stop pointer to point to the new top element of the stack, which is the previous element before the one you just popped. Okay, lastly, the pop element is returned or kept for further processing depending on the implementation and usage. All right, for this next one, I'm gonna leave it to Saya Azmi.
Now we got the push operation. For the push operation, you have an element that you want to store in the stack. If the stack has a maximum size and is already full, this is usually called a stack overflow, and the element cannot be added. If the stack is not full, place the element at the top of the stack. Next, we will have to update the pointer that always point to the top of the stack, often referred to as top in programming. Okay,
Okay.
now I will pass this slide to Swaimi. Thank you.
Okay, how the application work, the operation. For example, push A going to page A, and push page A going to page B. If pop page B going back to page A. So how it work? Push equal in bracket page. You will see a new page. It get added on top, which is your history. Pop equal you go back to the current page. Is okay. My bad. The current page is removed. And you see the previous one.
Okay, thank you.
Okay. Okay. For the graph push and pop, as you can see, the graph is going up when when push loading new page add to history stack A to A and B to A and B and C. Pop when the pressing back, remove top item, which is remove C from the list and remove B from the list and back to A. LIFO principle, the last page visited C is the first to exit on the back.
Okay, now the algorithm. History stack check. First, browser maintains a LIFO last in first out stack of visited page. Example stack, home, product, cards. All that is a current page. On back click, pops the top entry from stack, loads the previous page from cache and network, restores scroll position and from data. Edge case, if stack is empty, the button is disabled. All right. In here, we have the user click back button. If the history stack is empty, if yes, it's do nothing or disable the button. If no, get previous page from history stack, then navigate to previous page, then update to the current page, and lastly, render the page content. All right. Now the code I will pass to my friend Said Hazmi. All right, please continue.
So for the code, we got three phrases. First, we got initialization. It's an empty stack or string named backtrack is created when the browser is initialized. This stack will store the URLs of the previously visited page. Additionally, another empty stack string named forward stack is created to store URLs when the user navigate backward to enable forward navigation. For the second phrase, we got visiting a new page. If there is a current page, it is pushed onto the back stack, saving it for backward navigation. The new URL become the current page. The forward stack is cleared since a new navigation erase forward history, just like in a real browser. For the last phrases, we got the pressing the back button. The current page, sorry, for the current page is moved to the forward stack so it can be restored if the user click forward later. The most recent page from the back stack is popped, removed, and become the new current page. If back stack is empty, the system returns cannot go back further, no history left.
Right.
Okay, and for the conclusion, the back button relies on the stack base approach, the track browsing history. When navigating each new page visit, push the previous uniform resource locator URL onto the stack, allowing instant backward traversal via pop. This ensures order of 101 efficiency while maintaining intuitive navigation, just like a real browser. This stack structure perfectly matches the last in and first out behavior users expect when pressing back.
All right, that's all from
Thank you.
us. Thank you.